All right, this is chapter 14, carboxylic acids, esters, amines, and amides. This will be 2 lectures long. The first lecture will cover sections 1 through 3, and then the last lecture will cover sections 4 through 6. And this will be the last chapter of Unit 5, which will be chapters 11, 12, and 14. Chapter 13 will be lumped in with the next unit, which basically is the biochemistry unit. So section 1 is on carboxylic acids, and a very short definition of carboxylic acids is that they are weak acids. But they're also a functional group, and you can see we have the carbonyl here, which we learned about previously, and we had in the previous, I guess, chapter 12, we had if there was an R group and an H, it's an aldehyde. If there's 2 R groups, it's a ketone. Now, if we change this R group to being an OH, we call that a carboxyl group or a carboxylic acid. All right, and these are extremely polar molecules, and they turn out to be weak acids, hence why we call them carboxylic acids. On this page, there are 3 pictures, essentially of the same molecule of propanoic acid, formerly known as propionic acid, which actually means, like in Greek, first fat. When they were first discovering this molecule, it was the first or smallest carboxylic acid that exhibited properties of fatty acids, and we'll talk about those in the next unit. But all fatty acids have a carboxylic acid group and an alkyl chain, and so this has that, and it was the smallest one. I mean, it only has 3 carbons, 1, 2, 3, but it behaves like a fatty acid, so it produces an oily layer, and it produces soap if you add some lye to it or potassium hydroxide to it. Naming carboxylic acids, first rule is to replace the E of the corresponding alkane at the end of the name with oic acid. So what you do is you just look at how many carbons are there. This one has 1 carbon, so that comes from methane. You take out the E and you put oic acid. Methanoic acid. And then for the next one, you've got 1, 2, 3, which comes from propane. Take off the E, and then you get propanoic acid. And then we've got 1, 2, 3 carbons in that chain. And then if we were to number it, because we have a substituent group, we've got 1, 2, 3. And so 2-methyl. And then the longest chain is 3, so it's propanoic acid. So you can see it follows the same rules that all of the previous things do, except for that oic acid part at the end of the name. Rule 2, if there are substituents, the carbon chain is numbered beginning with the carboxyl carbon. And so what we could do is, if we ignore the carboxylic acid portion of this, all right, there's a carbon right there, but the rest of those let's ignore, all right? This benzene ring with 1 carbon, technically that molecule is toluene, but if we were to have an R group off of that carbon, the portion over here is called a benzyl group, which I mentioned in a previous lecture, and so that's why we call this benzoic acid. Essentially, that whole group, including the carbon, is a benzyl group, so it must be up to there, benzoic acid. Now, like this says, if there are substituents, the carbon chain is numbered beginning with a carboxyl carbon. All right, so around, and that means this carbon right here on the chain. So that's carbon 1. And then you could, if you were to number it this way, you'd have chlorines at 4 and 5, or as it shows, at 3 and 4. And so obviously you use the ones with the smallest numbering, which makes it the 3,4-dichlorobenzoic acid. So the table here has the structures and names of some of the simplest carboxylic acids. So the first one there is methanoic acid or formic acid. You might remember that formaldehyde is the simplest aldehyde, which looks like this. And so there's a connection here of these names. Even though this isn't the technical IUPAC name of it, you get that formic acid, formaldehyde. Also, for the second one, the simplest, or the second simplest carboxylic acid is ethanoic acid, but it's named acetic acid. This is from vinegar. There's a connection there to where we have the simplest ketone, which is this, and that's a terrible drawing, so I apologize, but that common name is acetone, acetic acid, acetone. What you'll notice, what connects these, is there are 2 carbons right there on acetic acid, there's 2 carbons right there on acetone. Then we have the one with 3 carbons, that's propanoic acid or propionic acid. And then the one with 4 is butanoic acid or butyric acid. If you were to go above and have 5 carbons, then it would be pentanoic acid. If it was 6, it'd be hexanoic acid, and so on and so forth. I want to point out here, butyric acid is the compound responsible for the smell of rotting butter. Its name, butyric, actually means butter in Greek, and it's also the primary smell of human vomit. And so it's not necessarily a good chemical to be around, but like the butane, which always has 4 carbons, that comes from this molecule, butyric acid, because it was the first one discovered for butter. You know, they took simple, important compounds or things like butter, found out that what gave it its smell, and especially the rotting butter in milk, was this compound. So since it's derived from butter, it's butyric acid. That's why it doesn't follow the numbering system like mono, di, tri, tetra, and then penta, hexa, hepta. It's all of these things come from common sources of names. Butyric acid happening to be from butter. The propionic acid was the first, smallest one that was a fatty acid, so they call it the first fat. Acetic acid literally means vinegar in Greek, or acid. They were kind of one and the same at the time, so they knew that basically spoiled wine was acetic or sour, and it was acidic, and so acetic acid. And finally, the formic acid is kind of a weird one, but it actually comes from the Greek word for ants, because they used to take ants, and I don't know why, but they would distill them, and the chemical that got out of there was called formica, which meant that it came from ant bodies. It was literally called ant acid, not like an antacid now you take to fix stomach problems. It was ant, like the bug, acid, so the acid you get from ants. And the formica is the genus name for ants, so that's what they called them. If you're wondering, the things that you have in your homes, formica is not related. It actually comes from the word mica, and a brand said this is for mica when they made synthetic mica, and so not related there, although it's exactly the same word. Example 1, write the IUPAC name for the following. So what we'll do is first count how many carbons there are. There's 1, 2, 3, 4, 5. Then we'll number the carbons. So we've got 1, 2, 3, 4, 5. The carboxylic acid is the main functional group there. So that's why that's number 1. And then we can see that there are 2 chlorines. So the name of this is going to be 2,4-dichloro, because that's the positions of both chlorines at the 2 and 4 position, and di because there's 2 of them. Since there are 5 carbons in there, it's going to be from pentane and then oic acid, because it is a carboxylic acid. So 2,4-dichloropentanoic acid.